Hello Math Wizards! Now we will continue our lesson with quadratic function. In the previous lesson, we identify the characteristics and properties of a quadratic function. And we also have the different forms of a quadratic function. We also have the representations of a quadratic function. We have discussed that a quadratic function can be represented by an equation, a graph, and a table of values. So now, we will be identifying one of the properties of a quadratic function, and that is the vertex of a quadratic function. So, in the previous lesson, we also identify two forms of a quadratic function. In standard form, which is f of x is equal to ax squared plus bx plus c, and the vertex form, which is f of x is equal to a times the square of x minus h plus k. In this case, we will be identifying the vertex of a given quadratic function. How important is the vertex in our quadratic function? A vertex is the turning point of the graph of a quadratic function. As what you can see in a graph of a quadratic function, it is the point wherein it reaches the highest value of the function, or it could be the lowest value of the function. It could be a maximum point or a minimum point in a quadratic function. So now let's have the function f of x is equal to a x squared plus bx plus c. Let us use this initial function and write it in vertex form. So we will be having f of x is equal to a x squared plus bx, be grouped in the function, plus c. We will be factoring out a in the group. So we will be having a times the quantity x squared plus b over ax plus c. Now let's complete the square. F of x is equal to a times x squared plus b over ax plus blank plus c minus blank. So in this case, we will complete the square. So we will be dividing or multiplying 1/2 to the linear term inside the parentheses. So you will be having b over 2a. Squaring it, you will have b squared over 4a squared. Multiplying it to our coefficient, it will become a times b squared over 4a squared. Writing the product in the second blank, it will become b squared over 4a. Continuing our solution, it will become f of x is equal to a times the binomial, the square of the binomial x plus b over 2a squared plus c times 4a minus b squared over 4a. In this case, we need to multiply c with 4a over 4a, so we could have c a denominator. We could make c a fraction with a denominator 4 over 8. Continuing our solution, we will have f of x is equal to a times x plus b over 2a squared plus negative b squared plus 4ac all over 4a. Based on our form, you have f of x is equal to a times x minus h squared plus k. Therefore, our h is equal to negative b over 2a, and our k will be 4ac minus b squared over 4a. Now, the formula in getting the vertex of a quadratic function, if it is written in standard form, is negative b over 2a for h, and k will be a 4ac minus b squared over 4a. And now let's identify the vertex of the given quadratic function with our formula. So the vertex will be negative b over 2a, 4ac minus b squared over 4a. One of the features of the vertex of a quadratic function tells us the maximum and minimum value of the given function. Maximum value if a is less than 0. Minimum value if a is greater than 0. So let's try. Y is equal to negative x squared minus 2x plus 3. Okay, so we will be rewriting the equation y is equal to ax squared plus bx plus c. So y is equal to negative x squared plus 2x plus 3. Distributing our negative sign outside, it means that ax squared, that the answer will be negative x squared plus 2x and add up 3. In this case, we could identify the value of h and k. So v is equal to negative b over 2a and 4ac minus b squared over 4a. So identifying the values of a, which is negative 1, b is equal to 2, and c is equal to 3. Now let us substitute for the value of h is equal to negative b over 2a. H is equal to negative of 2 over 2 times negative 1. H is equal to negative 2 over negative 2. H is equal to 1. For k, let's have 4 times 4ac minus b squared over 4a. K is equal to 4 times negative 1 times 3 minus 2 squared over 4 times negative 1. K will be equal to 4 times negative 1 times 3 is negative 12 minus 4 all over negative 4. K is equal to negative 16 over negative 4. K is equal to positive 4. Therefore, our vertex is 1, 4. Now let's identify the maximum or minimum value of the function. In this case, the value of a is less than 0. Therefore, f of x has a maximum value at y is equal to 4. Why 4? 4 stands for k in our vertex. So we'll be having at y is equal to k. Now let's have y minus 4 is equal to 4x squared minus 8x. In this case, we need to write in y is equal to ax squared plus bx plus c. Y is equal to 4x squared minus 8x plus 4. Identifying the values of a, b, and c, a is 4, b is equal to negative 8, and c is equal to 4. With the formula, h is equal to negative b over 2a, and k will be equal to 4ac minus b squared over 4a. H is equal to negative of negative 8 over 2 times 4. H is equal to negative of negative 8 is positive 8 over 8. H is equal to 1. Now let's have k. 4 times 4 times 4 minus b squared, which is negative 8 squared all over 4 times 4. K is equal to 4 times 4 times 4 is 64 minus negative 8 squared is 64 over 16. K is equal to 0 over 16. K is equal to 0. Therefore, our vertex is 1, 0. Since the value of A is greater than 0, therefore, f of x has a minimum value at y is equal to 0. Now let's have 2x squared plus 8x is equal to 4 minus y. In this case, we need to rewrite the equation in standard form. So y is equal to negative 2x squared minus 8x plus 4. So let's identify A, negative 2, B is negative 8, and C is equal to 4. And the formula in getting H is negative B over 2A, and K is 4AC minus B squared all over 4A. Now let's have H. Negative of negative 8 over 2 times negative 2. H is equal to 8 over negative 4. H is equal to negative 2. K is equal to 4 times negative 2 times 4 minus negative 8 squared all over 4 times negative 2. K is equal to 4 times 4, 16 times negative 2 is negative 32 minus 64 all over 4 times 4 times negative 2, we will give negative 8. K is equal to negative 32 minus 64 is 96. Negative 96 over negative 8. Dividing, K will be equal to positive 12. So our vertex is negative 2, 12. Since the value of A is less than 0, therefore, f of x has a maximum value. F of x has a maximum. Therefore, f of x has a maximum value at y is equal to 12. Let us consider 3x minus 6 is equal to 12x squared minus y. In this case, we need to rewrite the equation y is equal to 12x squared minus 3x plus 6. So identifying the values of A, 12, B is equal to negative 3, and C is equal to 6. H is equal to negative B over 2A, and K is equal to 4AC minus B squared all over 4A. H is equal to negative of negative 3 over 2 times 12. H is equal to 3 over 2 times 12. We could reduce 3 and 12. That will become 1 and 4. H is equal to 1 over 2 times 4, 8. K is equal to 4 times 12 times 6 minus negative 3 squared all over 4 times 12. K is equal to 4 times 6 is 24 times 12 is 288 minus 9 all over 4 times 12. K is equal to 93 over 16. Therefore, our vertex is 1 over 8, 93 over 16. Therefore, since our A is greater than 0, therefore, f of x is minimum at y is equal to 93 over 16. We could also identify the vertex of a quadratic function given the table of values. Let's say you have the values of x, negative 1, 0, 1, 2, and 3, and the values of f of x is negative 10, negative 19, negative 22, negative 19, and negative 10. We could identify the vertex. Observe first the values of f of x. At what values you think it becomes equal to the other values? So Upon looking negative 10, negative 19, negative 22, negative, it becomes again negative 19 and again negative 10. It means that negative 22 is the middle value of f of x. Therefore, the vertex for this table of values is 1, negative 22. Okay, now let's consider the second example. I want you to identify between the values of y that will make a symmetry in the values of the number. Upon seeing the values of y in negative 15, negative 3, 1, and then you have negative 3 again and negative 15, it seems that 1 is the turning point. Therefore, our vertex is negative 4, 1. The same with the third example, we could identify that the value or the turning point of the given table of values is at 3, negative 2. Therefore, the vertex is 3, negative 2. The same with this example. I think you already know the answer, and that is negative 2, negative 21 as the turning point of the values of x and y. Continuing, given the graph, you may also identify the turning point of the graph in the given example. In this case, the coordinates of the turning point is at 3, 2. Therefore, the vertex is 3, 2. The same with this one, you could see that the turning point is at negative 1, 3. Therefore, the vertex is negative 1, 3. The same as what we have in this graph, you have the turning point negative 3, negative 2, negative 3. Therefore, our vertex is at negative 2, negative 3. Let's have practice exercises and answer the 5-item questions that I will be giving. Choose the letter that corresponds to the correct answer. If your answer is not among the choices, write E. Find the vertex of the given function below. A, 1, negative 1, B, 0, negative 2, C, negative 5, 16, and D, 5, negative 9. Number 2. Find the vertex of the given function below. Letter A, 5, negative 9, B, 1, negative 1, C, 3, negative 25, and D, 0, negative 2. Number 3. Find the vertex of the given function below. A, 1, negative 1, B, 0, negative 2, C, 3, negative 25, and D, negative 5, 16. Number 4. Find the vertex of the given function below. A, negative 5, 16, B, 1, negative 1, C, 0, negative 2, and D, 3, negative 25. Now let's have number 5. Find the vertex of the given function below. A, 1, negative 1, B, 5, negative 9, C, 0, negative 2, and D, 3, negative 25. We will be checking your practice exercises on the next video. Like, share, and comment your suggestions on the comment box below, and don't forget to subscribe. To get notified with our latest videos, just click the notification bell.